Okay, so this whole video is about a very, I think, interesting concept, this idea of co-evolution. Okay, co-evolution, I believe we've talked about this before in our evolution unit. But co-evolution is when two organisms kind of propel or drive different traits to be specialized in those organisms over time. So kind of a classic example, I'm going to do some really bad drawing here. Think about like a gazelle. Here's my gazelle. Here's its head. Maybe give it some antlers. A gazelle and a lion. It's a lion. Give it its mane. All right, so say a pack of lions are hunting gazelle. Which gazelle get eaten first? The slowest, right? So the slowest gazelles are more likely to die. Which ones are more likely to survive, and not only survive, but reproduce? The fastest ones, right? So if the slowest gazelles die and the fastest ones are more likely to reproduce, then our resulting next generation of gazelle are going to be slightly faster than the previous one, right? Because the slow ones die, the fast ones reproduce. What about the lions? Well, same thing. The faster lions are the ones that are able to catch the slower gazelles. The slower lions are less likely to get food and survive and reproduce. So this is where it's kind of like an evolutionary arms race, where they're both trying to catch each other. And so the gazelles are getting quicker after each generation, and the lions are getting quicker after each generation. So they are both becoming faster over time. They're both driving this coevolution, this evolution between two different animals. So with that in mind, we're going to look at coevolution in terms of pollinators and angiosperms, or plants, flowering plants, right? Because we know flowering plants want to disperse their pollen in different areas. They want to cross-pollinate, so they want to become more genetically diverse. They don't want to self-pollinate, though some angiosperms do that. So what we have to do, we have a list of pollinators, and we have a list of angiosperms, and we have to match up which pollinator kind of goes to which angiosperm. Now, keep in mind that there is a best choice for each relationship. So if you don't find the answer, keep looking, because there will be a kind of straightforward or given answer if you do enough digging in the internet. So there's also research you have to do for each angiosperm. So we're going to do hardy fuchsia. We're going to look at that a little bit together in terms of just how it gets pollinated. So make sure, also keep in mind, we have to have the website source, so just include the link with that. So let's do some digging. So let's see. So what I would type in, I wouldn't just type in the name. You want to type in pollinator as well, because that's going to give you kind of a clearer answer. All right. So, and right away I can see in the first sentence of the first link, the hardy fuchsia is adapted for hummingbird population in a variety of ways. All right. So then we can go back here. We know right away we have hummingbirds on the pollinator side. That goes with hardy fuchsia. So we can go ahead and write that in. We'd also need to include our link for that. And then important characteristics for pollination. We want to basically talk about why is this kind of important. Okay, so how are the hummingbirds able to keep pollination going? And hummingbirds are really cool because their beaks can become really specialized over time. And angiosperms become really specialized in terms of making it so that only hummingbirds can get to their nectar and help pollination. So we can see here, these are just pictures I found online, but there's some really cool documentaries on it too about how, these beaks have become curved over time and really long over time to get through the petals of the flower to get to that nectar, right? So just kind of keep researching each one. Again, there should be a definite answer for each one, so keep researching. If you're having troubles, just know what to type in. And if you have any questions, let me know.